بسم الله الرحمن الرحيم. أبناء الطلاب وزملاء أطباء الدراسات العليا، يسعدني أن أقدم لكم هذه الأفلام التعليمية التي تتناول الجانب العملي لمادة التشريح. فلنشاهد الآن هذا الشريط على أمل أن يحقق الفائدة المرجوة منه مع تمنياتي لكم بالتوفيق. يقول الله تعالى: وقل اعملوا فسيرى الله عملكم ورسوله والمؤمنون. صدق الله العظيم.
This is the human brain. The brain is surrounded by three meninges called dura mater, arachnoid matter, and pia mater, as arranged from outside inwards. These three membranes are continuous with those of the spinal cord through the foramen magnum. As the brain is removed from the cranial cavity, it comes out with the pia mater. This is the brain with the covering pia mater. It is a soft vascular membrane which directly covers the surface of the brain and dips into its sulci and fissures. This is the pia mater, seen dipping into a sulcus on the surface of the brain, carrying with it the blood vessels. Between the pia mater and arachnoid matter lies the subarachnoid space, which is filled with the cerebrospinal fluid. There are sites where the subarachnoid space is deeper than elsewhere and are called subarachnoid cisterns. Here lies the cerebellomedullary cistern, which lies on the back of the brain stem between the medulla oblongata and the cerebellum. Here lies the cisterna pons, which lies in front of the pons and the medulla oblongata and contains the vertebral and basilar arteries. Here is the interpeduncular cistern, on the base of the brain, where it fills the interpeduncular fossa. This is the interpeduncular fossa, in front of the two cerebral peduncles. It contains the arteries of the circulus arteriosus. This is the cistern of the lateral sulcus and contains the middle cerebral artery. This is the middle cerebral artery. Let us start with the veins of the brain. They lie either on the surfaces of the hemisphere, where they drain the cerebral cortex and are called external veins, or lie inside the hemisphere, where they drain the basal nuclei and nerve tracts and are called internal veins. In general, the venous blood from the brain goes to the dural venous sinuses, for example the cavernous, transverse, and petrosal sinuses, and eventually through them to the internal jugular veins. The veins on the upper part of the superolateral surface converge on the superior sagittal sinus. The veins on the lower part of the surface drain into the superficial middle cerebral vein, which lies between the lips of the posterior ramus of the lateral sulcus and carries the blood to the cavernous sinus. On the medial aspect of the hemisphere lies the great cerebral vein. It emerges just below the splenium of the corpus callosum. It is formed by the union of the two internal cerebral veins, each of which drains one hemisphere. The great cerebral vein, which is a single vein, passes backwards to join the inferior sagittal sinus to form the straight sinus, which lies in the midline of the tentorium cerebelli. This is the opening of the cut great cerebral vein, emerging under cover of the splenium of corpus callosum. Here lies the straight sinus in the midline of the tentorium cerebelli, which covers the upper surface of the cerebellum. This is the cerebellum, and these are the occipital lobes of the cerebral hemispheres. Now, let us demonstrate the arteries of the brain, which are more important. The arteries of the brain are derived from two sources. The first source is from the internal carotid arteries, each of which enters the skull through the carotid canal. The second source is from the vertebral arteries, which enter the skull through the foramen magnum. This is the internal carotid artery, seen after leaving the cavernous sinus. It ends immediately below the anterior perforated substance of the brain, just lateral to the optic chiasma, where it gives off the middle cerebral and anterior cerebral arteries, in addition to the posterior communicating and anterior choroid arteries. This is the cut end of the internal carotid artery. This is the middle cerebral artery. This is the anterior cerebral artery. This is the posterior communicating artery. And this is the anterior choroid artery. This is the optic chiasma. And this is the anterior perforated substance just lateral to the chiasma at the base of the brain. And this is the cut end of the internal carotid artery just lateral to the optic chiasma. This is the posterior communicating artery. It passes backwards to join the posterior cerebral artery. This is the anterior cerebral artery. It runs forwards above the optic chiasma to gain the medial side of the cerebral hemisphere. Near its origin, it joins its fellow of the opposite side by the anterior communicating artery. This is the medial surface of the brain, showing the course of the anterior cerebral artery. This is the beginning of the artery, as it passes above the optic chiasma. It then curves around the genu of corpus callosum and then passes backwards on the medial surface of the brain as far as the parieto-occipital sulcus. That's to say, about the level of the splenium of corpus callosum, where it ends. It gives off cortical branches to the cortex of the brain on the medial surface of the hemisphere. Its branches cross the superior border of the hemisphere to supply 1 finger breadth of the superolateral surface. Note that This artery supplies the leg and the perineum area, which lies in the paracentral lobule on the medial surface of the hemisphere. It also gives off central branches. These are the central branches which perforate the anterior perforated substance to supply the interior of the hemisphere. This is the middle cerebral artery, arising from the internal carotid artery. It runs in line with the internal carotid artery and thus is more frequently involved by emboli which pass through the artery. The middle cerebral artery at first runs laterally in the stem of the lateral sulcus. Then backwards on the floor of the insula. This is the insula, and this is the middle cerebral artery running on its floor. To expose this artery, one has to open the lips of the insula. Alongside the artery runs the deep middle cerebral vein. The middle cerebral artery gives off cortical and central branches. The cortical branches supply the cortex of the superolateral surface, except the uppermost 1 finger breadth, which is supplied by the anterior cerebral artery. These are the cortical branches of the middle cerebral artery, coming out through the lips of the lateral sulcus. The central branches enter the anterior perforated substance to supply the corpus striatum. Hence, they are called striate arteries. It should be noted that the central branches are end arteries as they do not anastomose with neighboring arteries, while the cortical branches anastomose with neighboring arteries on the surface of the cortex. But once they pierce the cortex, they do not anastomose anymore. Obstruction of an end artery leads to destruction of the area of brain tissue supplied by this artery. This is the anterior choroidal artery, passing to the inferior horn of the lateral ventricle. This is the fourth part of the vertebral artery. The two arteries unite together at the lower border of the pons to form the basilar artery. Each artery ascends on the anterolateral aspect of the medulla oblongata, close to the rootlets of origin of the hypoglossal nerve. It gives off medullary branches to the anterior part of the medulla. It also gives off the anterior and posterior spinal arteries which descend to supply the spinal cord. Also, it gives off the posterior inferior cerebellar artery. This is the posterior inferior cerebellar artery, which is the largest and more important branch. It passes backwards with a tortuous course among the rootlets of the glossopharyngeal and the vagus nerves on the side of the medulla to reach the inferior surface of the cerebellum. It supplies the lateral aspect of the medulla as well as the inferior surface of the cerebellum. If obstructed, it leads to what is called lateral medullary syndrome or posterior inferior cerebellar artery syndrome. This is the posterior inferior cerebellar artery in another specimen. This is a medullary branch to the medulla. This is a spinal branch descending to the spinal cord. This is the basilar artery. It runs in the midline of the anterior aspect of the pons in a sulcus called the basilar sulcus. It begins at the lower border of the pons and ends at its upper border by dividing into two posterior cerebral arteries. It gives off pontine branches to the pons, labyrinthine artery, which enters the internal auditory meatus, the anterior inferior cerebellar artery, to the anterior part of the inferior surface of the cerebellum. The basilar artery also gives off the superior cerebellar artery to the upper surface of cerebellum, and then it ends by dividing into the two posterior cerebral arteries which supply the occipital lobes of the brain. This is the posterior cerebral artery. It winds backwards on the lateral aspect of the midbrain to sink into the calcarine sulcus on the occipital lobe of the brain. The posterior cerebral artery gives off central branches which perforate the base of the brain at the posterior perforated substance. And then ramifies on the surface of the occipital lobe. Each posterior cerebral artery receives the posterior communicating artery, which is a branch from the internal carotid artery, thus forming the circulus arteriosus, or the so-called circle of Willis. This circle lies in the interpeduncular fossa at the base of the brain and is formed as follows. First, by the two anterior cerebral arteries, which are joined by the anterior communicating artery. Second, by the two posterior communicating arteries, as they arise from the internal carotid arteries of both sides. Thirdly, by the two posterior cerebral arteries as they arise from the basilar artery. The importance of this big anastomosis is to allow the blood to circulate between the internal carotid arteries and the vertebro-basilar system, as well as between the arteries of both sides. This is the circle of Willis in another specimen, seen as diamond-shaped. These are the two anterior cerebral arteries. These are the posterior communicating arteries. And these are the two posterior cerebral arteries. Now, let us demonstrate the parts of the brain. The brain consists of two cerebral hemispheres, two cerebellar hemispheres, and brain stem. The brain stem consists of the medulla oblongata, pons, and midbrain from below upwards. The medulla oblongata extends from the lower border of the foramen magnum to the lower border of the pons. It is bulb-like, and hence lesions in the medulla leads to bulbar paralysis, and the pyramidal fibers ending in the brain stem are called corticobulbar fibers. This is a sagittal section in the brain stem to show the parts of the medulla oblongata. The medulla oblongata is divided into two parts called open medulla and closed medulla. The open medulla is the upper part and fourth ventricle behind it, while the closed medulla is the lower part and has a central canal inside it. By open medulla is meant that its posterior part is open to form the fourth ventricle. This is the anterior surface of the medulla. It shows the anterior median fissure in the midline. On each side of this fissure lies a pyramidal elevation called the pyramid. This pyramid contains the pyramidal or corticospinal fibers, which are the upper motor neuron fibers. Lateral to the pyramid lies the olive, which is an olive-like swelling produced by a big nucleus called the olivary nucleus, which is a part of the extrapyramidal system. The groove between the pyramid and olive shows the fine rootlets of the hypoglossal nerve. The hypoglossal nerve is the 12th cranial nerve and supplies the muscles of the tongue. Notice the close relation of the hypoglossal nerve to the pyramid, because if a lesion occurs here, both structures are vulnerable to the damage. This condition is called alternating hypoglossal hemiplegia. Lateral to the olive lies a longer elevation passing from the middle of the side of the medulla to the cerebellum. and is called the inferior cerebellar peduncle. It carries mainly, but not wholly, fibers from the spinal cord and medulla oblongata to the cerebellum. The groove between the olive and the inferior cerebellar peduncle shows the rootlets of the glossopharyngeal, vagus, and accessory nerves as arranged from above downwards. The glossopharyngeal is the 9th cranial, the vagus is the 10th cranial, while the accessory is the 11th cranial. At the junction between the medulla and the pons, notice the attachment of the abducent or 6th cranial nerve at the base of the pyramid. Notice also the attachments of the facial, which is the 7th cranial, and the auditory, which is the 8th cranial. Both lie on the side in line with the 9th, 10th, and 11th nerves at an angle called cerebello-pontine angle. At this angle, notice the presence of the lateral termination of the choroid plexus and the lateral aperture of the 4th ventricle. A tumor of this angle will compress the 7th and 8th nerves as well as the neighboring cerebellum. Notice that each of the cranial nerves as a whole has a deep origin from a nucleus or more inside the brain stem and leaves the brain surface at its superficial attachment. The olfactory and optic nerves, which are the 1st and 2nd cranial, are attached to the cerebral hemispheres directly. This is the posterior surface of the medulla oblongata. Its lower half shows the gracile and cuneate fasciculi as longitudinal bands on each side of the posterior median sulcus. The gracile fasciculus or tract is the medial, while the cuneate fasciculus is the lateral. These two fasciculi end above in the gracile and cuneate tubercles. This is the gracile tubercle, and this is the cuneate tubercle, which are produced by the gracile and cuneate nuclei. The upper half of this surface of the medulla enters into the formation of the 4th ventricle as it belongs to the open medulla. This is the pons. Its anterior or basilar part shows the sulcus for the basilar artery. From each side of this basilar part, the middle cerebellar peduncle runs laterally to enter the cerebellum. At the junction between the body of the pons and the middle peduncle lies the superficial attachment of the trigeminal nerve, which is the thickest cranial nerve, which is cut flush with the surface of the pons. On the surface of the pons, notice the perforation of the pontine vessels, which are branches from the basilar artery. This is the posterior surface of the pons. which forms the floor of the fourth ventricle and will be described soon with the fourth ventricle. This is a cut section of the midbrain, which is the upper part of the brain stem. It shows the cerebral aqueduct which traverses the midbrain vertically near its posterior part and connects the third ventricle above with the fourth ventricle below. The plane of the cerebral aqueduct separates the tectum posteriorly from the tegmentum anteriorly. The tegmentum is related anteriorly to a dark strip of gray matter called substantia nigra, which separates the tegmentum from the crus cerebri. This is the crus cerebri, one on each side, and consists of descending fibers. The middle 3/5 of the crus lodges the pyramidal fibers, which continue downwards in the basilar part of the pons and then in the pyramid of the medulla oblongata, and finally form the corticospinal fibers. The midbrain consists of two cerebral peduncles, one on each side of the midline. This is the right peduncle and this is the left peduncle. Each peduncle consists of the crus cerebri anteriorly, followed by the substantia nigra, then more posteriorly by the tegmentum. They should be differentiated from the cerebellar peduncles which connect the brainstem with the cerebellum. This is the posterior aspect of the midbrain, showing the tectum, which consists of 4 colliculi, 2 superior and 2 inferior. The superior colliculus is a reflex center for vision, while the inferior colliculus is a reflex center for auditory impulses. The superior colliculus is connected with the lateral geniculate body by a ridge of fibers called the brachium of superior colliculus. The inferior colliculus is connected with the medial geniculate body by a similar brachium called the brachium inferior colliculus. This is the inferior colliculus. This is the inferior brachium, and this is the medial geniculate body. This is the superior colliculum. This is the superior brachium, and this is the lateral geniculate body. The medial and lateral geniculate bodies form what is called the metathalamus, which is a part of the diencephalon. Just below the inferior colliculus, the superior cerebellar peduncle sinks into the back of the midbrain, one on each side of the midline. This is the frenulum velar, extending from the midline between the two inferior to the upper part of the roof of the fourth ventricle. This is the pineal body, lying in the midline above the two superior colliculi. This is the lateral aspect of crus cerebri of midbrain, crossed by the posterior cerebral artery and the optic tract, which ends in the lateral geniculate body. The optic tract crosses the uppermost part of the side of the crus. The posterior cerebral artery passes backwards from its origin from the basilar artery to reach the occipital lobe. This is the midbrain seen from the back in another specimen to show the trochlear nerve as it emerges from the back of the brain stem just below the inferior colliculus. This is the inferior colliculus. This is the trochlear nerve as it curves forwards on the lateral side of the crus of the midbrain. This is the anterior aspect of the midbrain, showing the two pleura which are separated by the posterior part of the interpeduncular fossa. Here, the oculomotor nerve, which is the third cranial nerve, leaves the midbrain on the medial side of the crus cerebri and runs straight forward. These are the structures in the interpeduncular fossa. This is the posterior perforated substance, which is the most posterior. These are the two mammillary bodies. This is the tuber cinereum. And here is the optic chiasma, which is the most anterior. The borders of the interpeduncular fossa are formed on each side by the optic tract anteriorly and the crus cerebri posteriorly. This is the cerebellum. It lies in the posterior cranial fossa on the back of the pons and medulla, from which it is separated by the fourth ventricle. It consists of two hemispheres and a median part called the vermis. This vermis bulges on the superior surface, where it is called superior vermis, and also bulges into a deep hollow on the inferior surface, where it is called the inferior vermis. The two hemispheres are partially separated anteriorly by an anterior notch which lodges the brain stem. And posteriorly by a posterior notch which lodges the falx cerebelli. This is the superior surface of the cerebellum. It shows multiple transverse fissures, the important of which are the fissura prima, horizontal fissure, and posterolateral fissure. This is the fissura prima, or primary fissure, which is V-shaped and cuts across the superior surface. Its apex lies at the junction of the anterior 2/3 with the posterior third and separates the anterior lobe from the middle lobe. This is the anterior lobe, and this big part is the middle lobe. However, The posterior lobe is a degenerated part on the inferior surface and is called the flocculo-nodular lobe and will be demonstrated soon. This is the horizontal fissure. It begins at the point of insertion of the middle peduncle and extends along the junction between the superior and inferior surfaces of the cerebellum to the posterior notch. The posterolateral fissure lies on the inferior surface and just behind the flocculo-nodular lobe. This is the inferior surface of the cerebellum. This is the inferior vermis. This is the flocculo-nodular lobe, which lies on the inferior surface of the cerebellum. It consists of the nodule, and the flocculus, together with the inferior medullary velum in between. This is the nodule, which is the most anterior part of the inferior vermis. The part of the inferior vermis just behind the nodule is called the uvula and is related on each side to a circumscribed mass called the tonsil. This is the tonsil. It lies on a bed formed by the inferior medullary velum. Thus, to display the inferior medullary velum, one has to remove the tonsil. Note that the inferior medullary velum stretches from the nodule medially to the flocculus laterally. This is a sagittal section in the cerebellar hemisphere. It shows the following features. These are the fissures which separate the folia. In the core of each folium extends a branch of white matter, thus giving the section a branched appearance called arbor vitae. This is the superior vermis in median section. Its most anterior part is called the lingula and rests upon the superior medullary velum just below the inferior colliculus. This is the inferior vermis in median section. This space is the fourth ventricle. This is its roof related to the cerebellum. And this is its floor formed by the pons and open medulla. The details of its description are coming soon. This is a horizontal section in the cerebellar hemisphere to show the dentate nucleus. It is called dentate because its surface has dentations like teeth. It gives rise to most fibers of the superior cerebellar peduncle. This is another horizontal section in the cerebellum which is stained to show the dentate nucleus. The dentations are clearly seen. Now let us demonstrate the fourth ventricle. This is the fourth ventricle, as seen in sagittal section. It appears as tent-like and lies behind the pons and open medulla, which form its floor. It is covered posteriorly by the cerebellum. Its roof is formed by the superior and inferior medullary vela. This is the superior velum, and this is the inferior velum. The ventricle is continuous above with the cerebral aqueduct, and below with the central closed medulla. This is the fourth ventricle as seen from the back after removal of the cerebellum. It appears to be diamond in shape and is wide at the level of junction of the pons with the open medulla. Here it extends laterally on each side to form a thin ependymal tube called the lateral recess. This recess runs on the back of the inferior cerebellar peduncle to open at the tip of the flocculus through the lateral aperture of the fourth ventricle. This is the cerebellopontine angle. This is the opening of the lateral recess of the fourth ventricle. This is the choroid plexus bulging through this opening. This is the flocculus. This is the ninth cranial nerve just anterior to the lateral recess. This is the seventh and eighth nerves emerging at the cerebellopontine angle, just above the flocculus. A cerebellopontine angle tumor will compress all these structures. The roof of the fourth ventricle is formed from above by the superior medullary velum extending between the two superior cerebellar peduncles, and from below by the inferior medullary velum extending between the two inferior cerebellar peduncles. This inferior medullary velum is removed with the cerebellum to expose the floor of the fourth ventricle. Inside the ventricle projects a choroid plexus of arteries surrounded by pia mater called tela choroidea of the fourth ventricle. It extends laterally on each side as far as the lateral aperture of the ventricle. This is the floor of the fourth ventricle. It is diamond-shaped and is bounded on each side by the superior peduncle, inferior peduncle, cuneate tubercle, and the gracile tubercle from above downwards. It is formed of a pontine part belonging to the back of the pons and a medullary part belonging to the back of the open medulla. The junction between the two parts is demarcated by bundles of fibers which run transversely from the median groove laterally towards the inferior peduncle and are called the medullary striae. The pontine part shows a medial swelling, a lateral swelling, and a superior fovea in between. The medial swelling, one on each side of the median groove, is called facial colliculus and is formed by the abducent nucleus together with the fibers of the facial nerve curving around it. The lateral swelling overlies the vestibular nuclei and forms the upper part of the vestibular area. This is the superior fovea, which is an angular depression between the two elevations. The medullary or lower part of the floor is divided by a depression called inferior fovea into three triangles. The medial triangle lies over the hypoglossal nucleus and is called hypoglossal triangle. The intermediate triangle overlies the dorsal nucleus of the vagus and is called the vagal triangle, while the lateral triangle overlies the vestibular nuclei and forms the lower part of the vestibular area. Now, let us demonstrate the cerebrum. This is the base of the brain. This is the interpeduncular fossa on the base of the brain. Its boundaries and contents have been mentioned before. It should be noted that the contents of the interpeduncular fossa form the floor of the third ventricle, and it is a part of the hypothalamus. And one should remember that the circle of Willis lies in this fossa. These are the two cerebral hemispheres, which are separated from each other by the longitudinal fissure, which lodges the falx cerebri. Each hemisphere has three surfaces and three poles. The surfaces are the superolateral, the medial, and the inferior surfaces. The inferior surface is divided into a tentorial part posteriorly in relation to the tentorium cerebelli and an orbital part anteriorly in relation to the roof of the orbit. The three poles are frontal, temporal, and occipital poles. Each hemisphere is divided into 4 lobes by 3 lines. One line corresponds to the central sulcus, and this line separates the frontal lobe in front from the parietal lobe behind. The second line extends from the parieto-occipital sulcus down to the pre-occipital notch, which is a notch on the inferolateral border, about 3 centimeters in front of the occipital pole. This imaginary line separates the parietal lobe from the occipital lobe. The third line is the posterior ramus of the lateral sulcus and separates the temporal lobe below it from both the parietal and the frontal lobes above. For the purpose of more clarification, The lines separating the lobes of the cerebrum from each other are demarcated by red lines. This is the central sulcus, and this is the frontal lobe. This is the parieto-occipital sulcus, and the line extended from it to the pre-occipital notch. And this is the posterior ramus of the lateral sulcus, and its backward extension. This is the parietal lobe behind the central sulcus. This is the temporal lobe below the posterior ramus of the lateral sulcus. And this is the occipital lobe behind the line of the parieto-occipital sulcus. Let us proceed to demonstrate the main sulci and gyri of the cerebral cortex. This is the superolateral surface of the left cerebral hemisphere. This is the frontal pole. This is the occipital pole, and this is the temporal pole. This is the central sulcus. It begins at the superior border, midway between the frontal and occipital poles, hence the name central. It passes downwards and slightly forwards to end at 1 inch behind the origin of the posterior ramus of the lateral sulcus, but does not cut into this sulcus. The central sulcus is always a single sulcus and is not interrupted as the case with the pre-central or post-central sulci, which may be divided into two parts. The central sulcus curves at the superior border of the hemisphere to cut into the medial surface. The area around its end is called the paracentral lobule. And it lodges the area for perineum and foot. The central sulcus intervenes between the pre-central gyrus and the post-central gyrus. This is the pre-central gyrus, and this is the post-central gyrus. The pre-central gyrus occupies the motor area from which most of the pyramidal fibers arise, while the post-central gyrus occupies the sensory area which receives the somatic sensations like proprioception, pain, touch, and temperature from the opposite side of the body. It should be noted that one cerebral hemisphere controls the opposite side of the body, that's to say, the contralateral side. This is in contrast to the cerebellar hemisphere, which controls the same side of the body, that's to say, the ipsilateral side. This is the lateral sulcus. It is called lateral because its stem runs laterally between the temporal pole and orbital surface. It transmits the middle cerebral artery. The stem ends on the superolateral surface by dividing into 3 branches or rami called anterior, ascending, and posterior. These are the anterior and ascending rami, which are short and cut into the inferior frontal gyrus. This is the horizontal longer posterior ramus, which forms the limit between the temporal lobe below it and both the frontal and the parietal lobes above it. If its lips are pulled apart, the insula is exposed in the floor of this sulcus, which is a hidden part of the cerebral cortex, having the middle cerebral artery running over its surface. This is the frontal lobe bounded by the frontal pole anteriorly and the central sulcus posteriorly. It is divided by two horizontal sulci into three frontal gyri: superior frontal, middle frontal, and inferior frontal gyri. The inferior frontal gyrus receives the anterior and ascending rami of the lateral sulcus, and this area is the motor speech or area of Broca. It is said to be well developed on the left hemisphere. Its damage leads to motor or expressive aphasia, that's to say, inability to speak. This is the precentral gyrus, and this is the precentral sulcus. It is parallel and in front of the central sulcus and carries the motor area where the body is represented from upside down with the leg in the uppermost part, while the tongue, larynx, and lips in its lowermost part. This gyrus corresponds to the course of the anterior division of the middle meningeal artery. And in case of hemorrhage from that artery, the hematoma may compress this gyrus, leading to paralysis on the opposite side, that's to say, contralateral hemiplegia. This is the parietal lobe. Bounded by the central sulcus anteriorly and by a line passing from the parieto-occipital sulcus to the pre-occipital notch. This is the parieto-occipital sulcus, which separates the parietal lobe from the occipital lobe. The main part of this sulcus lies on the medial surface, but it cuts into the superior border of the hemisphere to appear on the superolateral surface. This is the reverse of the central sulcus, which runs most of its course on the superolateral surface, but curves on the medial surface for a short distance. The parietal lobe shows the following sulci and gyri. This is the post-central sulcus, forming the posterior boundary of the post-central gyrus, which carries the sensory area of the opposite side of the body, with the body being represented in it in an upside-down way, the same as in the precentral gyrus. This cortical sensory area receives the sensations conveyed by the medial lemniscus, trigeminal lemniscus, and spinal lemniscus. These sensations are proprioceptors, pain, touch, and thermal. The curved gyrus around the end of the posterior ramus of the lateral sulcus is called supramarginal gyrus, while the part around the end of the superior temporal sulcus is called angular gyrus. These supramarginal and angular gyri are important centers for recognition of the structures and their meanings, a condition called stereognosis. It also contains the sensory speech area in which the meaning of spoken words can be recognized. An injury to this area leads to what is called sensory or receptive aphasia, which means inability to understand spoken or written words. This is the occipital lobe, bounded by the occipital pole posteriorly and by a line passing between the parieto-occipital sulcus and the pre-occipital notch. It shows a curved sulcus near the occipital pole called Leonate sulcus. It lies at the terminal end of the calcarine sulcus. The calcarine sulcus lies mainly on the medial surface of the hemisphere. The Leonate sulcus forms the limit of the visual area on the superolateral surface. The main site of the visual area is around the calcarine sulcus on the medial surface. This is the temporal lobe. It is bounded by the temporal pole, the posterior ramus of the lateral sulcus, and posteriorly by a line passing from the parieto-occipital sulcus to the pre-occipital notch. It is divided by two horizontal parallel sulci called superior and inferior temporal sulci into three gyri called superior, middle, and inferior temporal gyri. The middle of the superior temporal gyrus carries the auditory area. This area extends deeply onto the buried gyri of the insula. Therefore, most of the auditory area is hidden by the lips of the posterior ramus of the lateral sulcus. Note also that the auditory area lies opposite the lower end of the post-central gyrus. To sum up, the sulci and the gyri on the superolateral surface, this is the central sulcus. This is the pre-central sulcus. This is the post-central sulcus. This is the pre-central motor gyrus. This is the post-central sensory gyrus. All are vertical. These are the superior, middle, and inferior frontal gyri, which are horizontal. The inferior frontal gyrus shows the anterior and ascending rami of the lateral sulcus, cutting into it. This is the posterior ramus of the lateral sulcus. This is the superior temporal sulcus. This is the inferior temporal sulcus, all running horizontally parallel to each other. This is the terminal end of the parieto-occipital sulcus. This is the Leonate sulcus, which is concave towards the occipital pole. Now let us move to the medial surface of the hemisphere. The medial surface is demarcated by the corpus callosum, which appears in cut section as a curved mass of white fibers having a genu anteriorly, a trunk, and splenium posteriorly. The distance between the splenium and the occipital pole is longer than the distance between the genu and the frontal pole. This is the calcarine sulcus, with its two rami thus forming a Y-shaped arrangement. It transmits the posterior cerebral artery. The continuation of the calcarine sulcus to the occipital lobe is called post-calcarine sulcus, while its ramus, which runs up to the superior border, is the parieto-occipital sulcus. The area bounded by the post-calcarine and the parieto-occipital sulci is triangular in shape and called cuneus. The quadrangular area just in front of the parieto-occipital sulcus and bounded anteriorly by the upturned terminal part of the cingulate sulcus is called precuneus. This is the cingulate sulcus or sulcus cinguli, which begins below the genu of corpus callosum and runs backwards parallel to the end near the splenium by turning upwards to reach the superior border. Shortly before its end, it gives off a vertical branch at about the middle of the corpus callosum. The area bounded by this vertical branch and the termination of the cingulate sulcus is called paracentral lobule, into which the central sulcus cuts. This lobule carries the motor and sensory area of perineum and foot. The gyrus bounded by the stem of the cingulate sulcus and the corpus callosum is called cingulate gyrus. The sulcus, which lies between the cingulate gyrus and the trunk of corpus callosum, is called callosal sulcus. The gyrus in front of the paracentral lobule as far as the frontal pole is called medial frontal gyrus. The sulci and gyri on the inferior surface of the hemisphere are as follows. This is the posterior tentorial part of the inferior surface. It shows two antero-posterior parallel sulci, the latter of which is called occipito-temporal sulcus and is divided into two parts. The medial sulcus is called collateral sulcus. This is the rhinal sulcus, which lies in line with the collateral sulcus and bounds the uncus laterally. This is the uncus, which is a center for smell. The gyri of this surface are as follows from lateral to medial. This is the lateral occipito-temporal gyrus. This is the medial occipito-temporal gyrus. This is the lingual gyrus, which is a center for vision. It runs below the stem of the calcarine sulcus and continues forwards below the splenium to merge into the parahippocampal gyrus. This is the parahippocampal gyrus, which forms the free medial border of the hemisphere. It lies close to the side of the midbrain. The parahippocampal gyrus is related deeply to a gray mass called hippocampus, hence the name parahippocampal gyrus. It continues forwards to form the uncus at the temporal pole. The uncus is bounded from the remainder of the temporal lobe by the rhinal sulcus. This is the orbital part of the inferior surface. It rests over the roof of the orbit. It shows an H-shaped sulcus, and its posterior limit is separated from the temporal pole by the stem of the lateral sulcus. Parallel to its medial border lies the olfactory tract, with its swollen anterior end called olfactory bulb. The olfactory bulb and the tract lie in the olfactory sulcus. The gyrus medial to the olfactory sulcus is called gyrus rectus. This is the olfactory tract. Following it posteriorly, it divides into medial and lateral parts, which enclose the anterior perforated substance. This substance is perforated by central arteries of the anterior and middle cerebral arteries. The olfactory bulb and tract form a part of the rhyncephalon, which is the part of the limbic system concerned with smell. This is another specimen showing the anterior perforated substance perforated by the central arteries. This is the paraterminal gyrus, lying in front of the lamina terminalis and below the rostrum of corpus callosum. This is the lamina terminalis, and this is the rostrum of corpus callosum. This is the cingulate gyrus, curving backwards around the splenium to become continuous with the parahippocampal gyrus. Note that just behind the splenium, the cingulate gyrus and the lingual gyrus join the parahippocampal gyrus. It should be noted that the cingulate gyrus and the parahippocampal gyrus are two main gyri of the limbic system.